Today, this is estimating the product of a decimal and a whole number. We'll be doing examples from the book, page 137, numbers 13 through 16, and I'll let you know when we're doing those, and I'll number them on the screen. And we'll be doing a word problem on page 138, number 19. Thank you, and follow along with the slides. Hey, fifth graders. Today we're going to be learning how to estimate the product of a decimal and a whole number. You remember clearly that estimating is rounding, and the product means the answer to a multiplication question. So good, I'm glad you remember that because we'll need those two terms today. I'm going to highlight this because things get a little weird when you multiply decimals. I know that when we added and subtracted decimals, we kept on drilling that you have to line up the decimals, line up the decimals. Well, guess what? Now that we're multiplying, we don't line up the decimals. We line up the numbers, not the decimals when we multiply. So this yes is what it looks like, right? 2 and 1500ths times 16. We don't make 16 into a decimal and then line them up. Cannot do it that way. So we're setting up the problem to look more like a 3 by 2, which we've been practicing that 3 by 2 multiplication, 3 digits on top and 2 on the bottom. So that's what we want it to look like. And I know this might sound rude, but we're going to ignore the decimal, at least for a little bit, and I'll show you what to do with it when we're done. There's a couple of concepts we need to review. One is, here's my decimal, okay? One concept we need to review is when you move the decimal to the right, the number gets bigger. And if we think that way and think about the decimal moving to the left, here's a decimal. When the decimal moves to the left, it gets smaller. The number gets smaller. Okay? And this is an important concept because we're going to be moving this decimal around. He gets shoved around and pushed around. So I apologize, decimal, that we're going to ignore you and push you around, but it's to get the right answer. And we all know how important getting the right answer is in math. So we'll apologize ahead of time to the decimal. Okay, let's get started with this example. This is example... There, I think you can see better with that. 2 and 1500ths multiplied times 16. So when I set that up, and it looks just like the one that says yes, right? So you might see it written like this first. 2 and 1500ths times 16. Now we are estimating, so that these numbers can change, right? So let's change, or let's round these numbers to something that we can work with. Remember when we round decimals that we're looking at the nearest whole number? Or I'm sorry, when we're rounding a number with a decimal in it, a whole number, we're looking for the nearest whole number. So we're going to round these decimals to that number. If this is the decimal here, the nearest whole number is the first digit to the left, right, the ones place. So same rounding rules apply since third grade. We go next door, we check the 1. If it's 4 or less, let it rest. 5 or more, raise the score. So since we're going next door and see that it's a 1, that's 4 or less, so that's going to turn to 0. So we have just the whole number 2. To make things easier, since we are going to be ignoring the decimal, I'm just going to write it as a whole number, 2. And I'm going to multiply that times 16, which is 16 closer to 10, or 16 closer to 20. Okay, 16 is closer to 20. So this one's actually easy because we have no decimals. 2 times 20, that's 40. Mr. B, you said decimals, and that is not a decimal. And you're right, because when we rounded the 2 in 1500ths, we rounded to a whole number of 2 with no decimals. So let's do one with a decimal and see if that changes the way we look at things. I want to move this out of the way because I don't think I'll have enough room to do another one there. Let's do example number 2. Let's do 104, and we'll multiply that times 33. And I'm just going to go ahead and set this up like a 3 by 2, so you can see I have 3 digits on the top, 2 on the bottom, and sorry, decimal, I'm going to ignore you for a little bit. So let's round these numbers. 104, that's closer to 100, and we're going to multiply by 33 hundredths, which I guess I can look at that like this. Is it closer to 30 or is it closer to 40? Well, it's closer to 30, so we'll leave it like that and we'll put our decimal. So we have 100 times 30 hundredths. So I have two options here. I can solve it with like a 3 by 2, get Bob in here to do his job. That's one option. The other option is, since I have all these zeros in the problem, I can set it up like the way I used to work with those a few days ago, where it looked like 100 times 30. And I wrote it more like an equation, like a number sentence, right? Because I remember that Mr. B said you can circle the numbers that aren't zeros, multiply those two together. 3 times 1 is 3. Count the zeros, 3 zeros, add them to the number. So I have 3,000. But what I have to realize here, using my number sense, is that 30 hundredths, that's not a whole number. So my number isn't actually accurate yet. I have to do something with the decimal because it's here. I've ignored it long enough, and now I have to pay attention to it. I'm going to push them around a little bit. So what I do is I take a look at how many places are to the right of the decimal. So here's the decimal. I have 1, 2 places. So I have 1, 2 places to the right of the decimal. If I move that number, if I move the decimal in this whole number of 3,000, this is where it would be. That's a whole number of 3,000. Right? I have nothing in the tenths, hundreds, and thousands, but the decimal needs to move. So I counted 2 spaces. So now I need to make this number smaller because right now it's too big. 3,000 is too big to be the product of 100 times 30 hundredths. So I need to move this decimal to the left to make the number smaller. And if you notice, I'm moving it twice because there are 2 spaces that I moved, that I counted in the top number. And now I'm going to move the decimal 2 places and drop it right there. I'm going to drop the decimal right there between that second and third zero. So that number now becomes 30. 30, the decimal would be there. And it's a whole number, so I actually don't even need the decimal because it's a whole number. So my answer would be 30. So 100 times 30 hundredths is 30. That is moving the decimal around a lot. And if you remember, when we were multiplying times 10, 100, and 1,000, the decimal got bigger and then moved to the right. So now we have to move the decimal to the left and make it smaller so that we can actually find our product. Let's do another one. Okay, here's our next example. This is not for the book yet, but we'll get to there in a second. This example would be 79 hundredths. 79 hundredths. And we're going to multiply that times 51. Okay? So let's, since we're estimating, we'll make sure that we estimate those numbers and round them. And 79, decimal, excuse me, but 79 is closer to 80, so we'll just go ahead and make that into an 80. And 51, that's easy. We can round that to 50. It's closer to 50. Okay, once again, we can solve this standard equation, make sure Bob does his job. But since I have zeros here, it makes it pretty easy. And at this point, I shouldn't have to rewrite it, but I understand if you still need to, so we can do that. And we'll write 80 multiplied by 50. Same rules apply. Since we're dealing with some zeros here, we can circle the numbers that aren't 0, multiply those. 8 times 5 is 40. And then we count 2 zeros, add those 2 zeros in. So we have 4,000. But there's no way that 50 times 80 hundredths can be 4,000 because 80 hundredths, this number here, is less than 1. So there's no way that multiplying that 50 times can get us to 4,000. That's way too big. So we're going to do the same thing we did earlier. We're going to count the decimal places after. So here's our decimal, and we went 1, 2. We have 2 digits after. So then we take our 4,000, which if this was a whole number, the decimal would be here, right? That would make it a whole number. But it's not because we didn't pay attention to the decimal when we multiplied. So now we're going to shove him around a little bit and move him the same amount of spaces in, which is 1, 2. And we're going to drop him there. I guess that's even if a decimal is a boy. I guess a decimal could be a girl. We're going to move her there. It. We're going to move it. We'll We're going to move the decimal 2 spaces and drop it there. So that means our answer is 40. That makes a little bit more sense. 80 hundredths multiplied 50 times would give us 40. Yeah, that's a number that I can work with. Let's do one more before we go into our book examples. This one we're going to do 9 and 2 hundredths multiplied by 82. And this one just happens to be set up to look like a 3 by 2. The decimal's there. He's hanging out. He's not hurting anybody. But we're going to ignore him. Sorry, dude. And let's round these. And we're just going to look at this as 9 and 2 hundredths. So it's either closer to 9 or 10. 9 or 10. And this is pretty close to 9, so I'm just going to round that to 9. And then I'm going to multiply 82. I'm going to round that, so that'll be 80. 9 multiplied by 80. It looks weird. Like I feel like the 2 digits should be on top, right? And that's why some people like to rewrite them to make more sense. And you can totally do that. You can rewrite this problem to look like 80 times 9. Or maybe you want to do 80 times 9 that way. Any way you decide to rewrite it, as long as you do the multiplication correct, then it's going to come out with the same product. Let's not get too confused. Let's erase this bad boy. We'll just do it the top one. And we're going to follow the same rules when we're dealing with multiplying by zeros. And we're going to circle the non-zeros, which is 8 and 9. 8 times 9 equals 72. And we have 1 0, so that means I got to move over and squeeze in 1 0. And my answer is 720. So 9 and 2 hundredths multiplied times 82 is about 720. And there's no decimals because the 9 turned into a whole number, so I don't have a decimal there. So there you go. That's another example. Now let's look at some examples from the book. All right, 5th graders, if you want to follow along, this one is on page 137 of your book, and it is number 13. Okay, and that shows, I'm going to write it just like it's written in the book, 1 and 67 hundredths multiplied by 4. Okay, so I have to estimate the product, so that means we're rounding. So what can we round 1 and 67 hundredths to? Well, if we're rounding a decimal, especially with a whole number, we could round to the nearest whole number, right? That's what we have been kind of practicing. So if this is the whole number, all right, remember rounding to the nearest whole number is the first number to the left of the decimal, which in this place, in the ones place, is a 1. And we go next door. 5 or more, we raise the score. So that 1 and 1 together become 2. And now I have a whole number. I don't need the decimal. I just have a 2. The 4, well, we don't round single digits. It's just a 4. He doesn't have to be rounded. 2 times 4 equals 8, which means our answer for number 13 is 8. Let's move on to number 14. Here's number 14. And that one is written as 3 and 2/10. And we're going to multiply that by 184. And since we're estimating, we can go ahead and change these numbers to some easy to work with digits. There we go. And 3 and 2/10 can round to, well, if I'm rounding to the nearest whole number, right? So I'm looking at the number to the left of the decimal, which is 3. And I'm going to go next door, check the score. 4 or less, let it rest, so that means it changes to a 0. So I just have 3. I'm not going to put the decimal there because, sorry, but he has gone bye-bye for now. And 184, is that closer to 100 or is that closer to 200? Well, 184 is closer to 200, so we just multiply by 200. And the same rule applies that we've been using when you're multiplying by zeros. Little quick trick is to multiply 3 and 2 because they're the non-zeros. That gives you 6. Count the zeros. We have 2 of them, so we add 2 here. And my answer is 600, which is very, very thick writing for some reason. But that is number 14. All right, let's go to number 15. Sorry, thick 600, you got to go. And number 15, if I looked as 14, let's put him up here where he belongs. Bye, 14. For number 15, we have written 12 multiplied by, there's the bell, 37 hundredths. So 0 and 37 hundredths. That's our problem. So, of course, we're still rounding, right, which is, I'm going to do that. And we'll round this one. And because we have 37 hundredths, we can't round that to the nearest whole number because there is no whole number. So we have to actually round it as if it was 37, right? Because there's nothing here in the whole number spot. So we're going to round that decimal as it is right there. So 12, and we could round that. 12, is that closer to 10? Oops. Or is that 10? Or is that closer to 20? 12 is closer to 10, and we're going to multiply that by, wow, so 37 hundredths. Is that closer to 30, or is that closer to 40? It's closer to 40, so I'm going to keep the decimal there because he wants to hang out right now, and there. So we have 10 times 40 hundredths. Okay, I'm dealing with zeros here, so I can follow the same rules, right? Multiply the digits that are not 0. 1 times 4 is 4. Count the zeros. I have 2 of them. Put them there. Now remember that the decimal, if this was a whole number, would be here. And it actually, we're not multiplying by a whole number because we have 40 hundredths. So we count the decimal places, 1, 2, that are the decimal places that are there. There's 2 of them. So then we're going to take the decimal and make the number smaller by going 2 decimal places to the left. 1, 2, and we drop it. We drop it right there. So it ends up being 4 and nothing, and no tenths and no hundredths, or we could just simply write it as the whole number 4. Okay? Okay, let's go into our last example in the book, which is page 16, and then we'll do our word problem. Okay, here is number 16. Let's do a red one. Number 16. And that is 904 thousandths. Ooh, getting spicy here. Multiplied by 75. Now you remember when we did the 37 hundredths, where is that at? Let's look at that again. When we did the 37 hundredths, we did it by 30 and 40. We rounded that way. Because if we were to round to the nearest whole number here, and we went next door, it's 4 or less, so that would make the number 0. So that doesn't make sense. It's just not big enough to round to one whole, and it's not possible to round it to 0. So that's why we did it that way. Now, the one we're doing with now, 904 thousandths, it's a little unique, right? Because it's close to 1, and if we were to go to the nearest whole number right here and go next door, it would be 5 or more, raise the score, and we would add 1. So that would make it 1. So that's why this number here, 904 thousandths, would round to 1, because it's very close to 1. And then we would multiply that times 75, because there's no need to round 75 if we're multiplying times 1. I mean, we could round it to 80, right? And since we're estimating, we would get about the same answer. We would get about 75 or about 80. So that would be that one, right? Let's go on to the word problem. Okay, so here's our word problem. It's on page 138, number 19. Okay, great. Finally, we have some answer choices, right? Answer choices are like basically a roadmap for the word problem, because they're going to tell you where you need to go to find the answer. There'll be some answers that don't make any sense, and then there'll be a couple that could be, but if you use your strategies and understand the question as much as possible, it'll be pretty easy to find the right answer. So let's go through this one. Marcy picked 18 8/10 pounds of peaches at the Pick Your Own Orchard. Each pound costs $1.28. Which is the best estimate for the cost of Marcy's peaches? Okay, there's my word estimate. So best estimate, that means I get to round, and she bought 18 and 8/10 pounds, and they cost $1.28. So I know I'm dealing with multiplication because that's the lesson, so I know my operation is multiplication. That part is at least done for me. Easy. Now I get to round. So I'm going to take 18 and 8/10, and I'm going to multiply that by $1.28. Okay, so my rounding, I have whole numbers, so I can round to the nearest whole number. That's at least a good bonus as well. 18 and 8/10, I can round that to 18 or 19, or I can make it super easy, right? I could round this to 18, to 19. I misspoke. Because going next door, 5 or more, raise the score. I could do it to 19. Yeah, absolutely. But why not make it super easy for myself, since I am estimating and I have answer choices to kind of guide me? Let's round that bad boy to 20. Oh, that's not an eraser. Let's round that to 20. I think that would be a really good idea. This is not erasing. That 19 is refusing to leave, so we're just going to cross it out. Get out of here, 19. Okay, so we're going to round it to 20. And we're going to multiply that by 1 and 28/100. Well, if I'm rounding to the nearest whole number, which is the number to the left of the decimal, I go next door, 4 less, let it rest or change it to a 0. Okay, cool. 20 times 1. That's easy. That's about $20. So if it's $20, I look at my answer choices. I have a 12. Well, I can get rid of the 52. It's nowhere near that. And that means the 40 is nowhere near that. So I have two choices here. I have $12 and $26. So which one is the closest to $20? That's what I would use to find out my answer, the best estimate, right? I would say that's $26. That to me makes the most sense. 12 doesn't seem quite enough. And if I really wanted to, I could solve the actual problem, but you have to wait till you learn how to multiply decimal by decimal. And at that point, you could solve it outright and figure out how close you are. But I think $20 is a pretty reasonable estimate, and I think we're going to be okay to choose that answer. All right, that's the word problem. I think I have one more before we go. Let's do one more word problem. Okay. This one says, a deli buys 30 and 4/10 pound of cheese each week. Which is the best estimate of the total amount of cheese the deli will buy in 4 weeks? Sometimes I have to read these twice because it's hard for me to understand the first time. So let me read it again. A deli buys 30 and 4/10 pounds of cheese each week. Which is the best estimate of the total amount of cheese the deli will buy in 4 weeks? Okay, here's a couple of hints. I know that the word each means one. And in this case, each week means 4 weeks. So there's actually 4 weeks. Okay. So 30 and 4/10 pounds of cheese in 4 weeks. 30 and 4/10 pound of cheese in 4 weeks. And I know I'm doing multiplication, right? I know that I'm still multiplying, so this is going to set myself up to find the answer. Okay, so let's round, right? That'll be my next step, is rounding 30 and 4/10. And since 4 is a whole number and it's only one digit, I don't have to round that. I just keep it as 4. 30 and 4/10. Well, is that closer to 30? Well, it is 30. So how do I round 30 and 4/10? Well, if I'm confused about how to round this number, I can just go always back to the tried and true round to the nearest whole number, which is the number to the left of the decimal. All right? So I'm going to start there because I'm not real sure what to do with 30 to make it 30 or 40, although I see that it's clearly closer to 30. But I want to make sure, so I'm just going to follow my rounding rules and go to the left of the decimal for the nearest whole number, which is a 0, go next door, and I have 4 less, let it rest, or change it to a 0. So that would make my rounded number 30. And I have 30 times 4. Follow the same rules. Multiply the numbers that are not 0. That's 12. 1 0 at the end. So my answer is 120 pounds. And there is my answer right there. Good job, guys. Feel free to pause, rewind. Make sure you get the notes at the beginning. And thanks for watching. See you next time. Peace.